So we're going over checking for understanding for significance test basics. For which of the following combinations of p-value and significance level would we fail to reject the null hypothesis? So the p-values here, the significance level, and you'll see that word occasionally, especially on your quizzes, that's the same thing as the alpha, all right? And we fail to reject if the p-value is greater than the alpha. In this case, 0.046, sometimes it helps to change the second number so they match the number of decimals. So this is 0.100. So you can see that it's actually, the alpha is bigger than the p-value, right? 0.44. So we would reject because our p-value is less than the alpha, right? And then here you have 0.050. That one, the p-value is actually greater than the alpha. So that's why I picked that as the answer. This alpha is 0.050. So the p-value is less than that number. And 0.4266 is less than 0.500. So sometimes if the number of decimal digits don't match, it helps to make them match by adding a 0 at the end, and then it's easier to compare. Over here, same idea. Change that to 0.100, 0.050, 0.050, 0.010. And here you can see the only time the p-value is actually bigger than the right number is on the last item, which is item D. All right. The article, poll finds most oppose return to the draft, wouldn't encourage children to enlist. So it was a random sample of 1,000 American adults. So there's our sample size. Let me go ahead. I always like to highlight the sample data. So we have 1,000 American adults. 700 indicated they opposed reinstatement of the military draft. Now, suppose you want to use this information to decide if there's convincing evidence. So the convincing evidence, this is what tells us what we're doing on our hypothesis test, that the proportion is actually greater than. So what we're going to do is we're going to take that number, that becomes our alternate hypothesis. All right? So convincing evidence that the proportion of American adults who oppose reinstatement of the draft is greater than that. Okay. And then the null always uses an equal sign, at least in this class. All right. So it has the same number as HA. So whatever number is down here, you use it again. Okay, so that's true here. Let's go ahead and look at the setup on this one. Here we have a survey of 1,000 adult Americans and who said playing the lottery would be the most practical way to accumulate $200,000 in net wealth. Okay. Suppose you want to, and there were 210. All right. Suppose you want to use the data, that shouldn't say date, that should say data, from the survey to decide, is there convincing evidence of what? That more than 20% believe that playing the lottery is the best strategy. Okay, so what should the hypothesis be? Well, again, that helps you, these numbers more than 20%, so that's HA right there. Here is greater than 2/3. There's your HA there. And then, of course, you use the same number for the null, and just make sure you use an equal sign. Sample size, you can see here, it was 1,000 for both of these. Sample statistic, which comes from the sample, it's 700 out of 1,000 here, or 0.700. And here it's 210 out of 1,000, or 0.21. So the p-value of this test is 0.013. What conclusion should you reach if alpha is 0.05? Well, that p-value is less than an alpha of 0.05. And if it makes it easier for you, add a 0 so you can see it's like 13 to 15 10,000s. So we reject H0 because the p-value is lower. We have convincing evidence that p is greater than 0.0067. And where does that convincing evidence come from? Well, the low p-value, and it's evidence for our alternate hypothesis, okay? So don't ignore the alternate hypothesis. That is a big piece of this. So that p is actually greater than 0.2, because here we also have the same situation. Well, we have a p-value of 0.215, which is kind of big, and it's definitely bigger than 0.05. So we fail to reject. We're like, we're not going to change our mind. We're going to stay. We think it's just 20% because we do not have convincing evidence that p is greater than 0.20.